I'm Steven,
And I'm Ian.
and this is the area of a kite. The area of a kite is diagonal 1 times diagonal 2 divided by 2. Now given the diagram as shown for this kite, we have that 8 radical 2 is AB, BC equals 17, and BE equals 8. Now using that knowledge, we can figure out that EC equals 15, and A equals 8, and AE equals 8 due to special right triangles. Now we have that, we can find the individual area for each triangle to 32 and 60 for respectively for each of the smaller and bigger ones. And then adding that together, we can get the total area of the kite to 184. Now when we use the normal formula for this, the one that's given the area of a kite, we have that 16 times 23 divided by 2 is like 368 divided by 2 equals 184. So that's how this formula works.
Alright, for this problem, we have kite LMNO. We have the fact that angle MLO is a right angle. We have MO equals 20, MN equals 23, and we're going to need to find the area of LMNO. And in order to do this, we need the length of the two diagonals so we can fill them in the formula. So the first step is to mark up the diagram. That's pretty simple. Now for the second step, we need to remember that the law of a kite states that one diagonal is the perpendicular bisector of the other, so therefore we can get two lengths of 10 that go from M to the middle to O. So next what we can do is, since we have two side lengths of a triangle, we can use the Pythagorean theorem to find the last side. And so we plug it into the Pythagorean theorem, x squared plus 10 squared equals 23 squared. And the end result of this equation is x is approximately 20. Alright, and from here, we need to find the length of the middle to L. And in order to do this, we need to remember facts about our special right triangles. So as you can see, this big triangle on the left, it is an isosceles triangle. From this we know that the sides opposite the angles are x, x, and x radical 2. And we're looking at the hypotenuse here, so we're going to be focusing on x radical 2. So since we already have the length as being 20, we can plug it in and say that 20 equals x radical 2. And once we solve for that, we get 10 radical 2 as being one of the side lengths. And from here, we can finally use the Pythagorean theorem to find the third side, and once we do, we get that it is 10. And now we add 10 to 20 to get the diagonal length that is horizontal, and from here we have both diagonals, so therefore we can plug it into the formula and solve. And once we do this, we get an end result of 300.